Good afternoon, students. Today I am going to explain few problems based on lenses, and whatever the problems that I am going to explain very important for the board exam. And you listen very carefully. If you have any doubt, you write in the chat box. Okay, right. Previously, in the last class, we discussed about the lens formula. Sorry, in the last class, we discussed about the mirror formulas. Now, today I am going to explain the lens formula. What is the mirror formula? That mirror formula we discussed is 1 by f is equal to 1 by v plus 1 by u. That is the formula for the mirror. Now, I am going to explain the thin lens formula. Okay, lenses are two types, same just like mirrors. Spherical mirrors are two types, convex and concave. Lenses also two types. What are the lenses? Lenses are two types. Lenses are two types. Lenses are two types. The first one is the convex lens and the second one is the concave lens. How convex lens will be there and how concave lens will be there? Okay, the convex lens and the concave lens, these are the part of spheres. Okay, and the convex lens is thicker at the middle and thinner at the edges. Concave lens is thinner at the middle and thicker at the edges. This is about two types of lenses that we are discussing, right? And next one is the thin lens formula. What is the thin lens formula? Will you tell what is the formula? Thin lens formula is what? What is the thin lens formula? 1 by f is equal to 1 by v minus 1 by u. This is the formula for the lens. What is u in this? U is the object distance. Is it clear, students? Clearly appearing now, voice and everything? Yes, Savan, it is correct. 1 by f is equal to 1 by v minus 1 by u. It is the formula for the thin lens. U is the object distance. U is the object distance and v is the image distance. Okay. F is the focal length. F is the focal length. Now tell me, object distance from where to where we have to take. This is an optical center, right? This is an optical center. So this is the principal axis. This line is called as the principal axis. For example, if object is placed at here, this is an object. Okay, this is the object. Its image is formed at here. This is the image, for example. Okay, and the object distance from optical center, that is called as the object distance. Okay, distance of object from optical center is called as object distance. Distance of image from optical center, where O is the optical center. Okay, O is the optical center. You can take as O dash. O is the optical center. Okay, right. Object distance of object from optical center, from O, from here to here, it is called as object distance. This is called as the image distance. F is the focal length. Okay, right. 1 by f is equal to 1 by v minus 1 by u, we have to write. Next, magnification formula I want. Can you write what is the formula for the magnification of lens? Magnification means what? Magnification is the height of image by height of object. Height of image by height of object. That means this is the object we are taking. Object height is HO and image height we can take as HI. The ratio between the height of image to the height of object is called as the magnification or the magnifying power. The formula for this one is, we can also write as image distance by object distance. Okay, you must remember. Now we have to go for the sign convention rules. According to sign convention rules, while solving problem, uh, we use some sign convention rules. What are they? The first sign convention rule is that, for example, in case of convex lens, first we go for the convex lens. Okay, and in case of convex lens, okay, in case of convex lens, the focal length is positive. You remember it. Object distance is always negative. Why? Focal length is positive. The convex lens forms the image like this. Okay, when the object is at infinite distance, light rays are incident like this, and after that they will pass us through focus, right? They will pass us through focus like this, and they will meet at a point. When the light rays parallelly incident, they meet at a point. That point is called as the focus. The focus distance from the center of the lens, this is the center of the lens. Focus distance from center of the lens is called as the focal length, right? Focal length. F is the focal length. Focal length is right side of the optical center. Right side of the, we know that optical center you should combine, you can compare with the coordinate system. This is the origin, and right side positive, left side negative, and above positive, below negative we have to take according to sign convention rules. And according to sign convention rules, object is left side, that's why object distance is negative. Focal length is positive for the convex lens. Okay, right. And now convex lens maybe forms the real image, maybe forms the virtual image. Right? If the convex lens forms the real image, the image will be right side. That means we have to take as image distance as positive. Image distance as positive. And image is inverted means magnification will be negative. Okay? Right. These conditions we have to take. In case of virtual image, actually in one situation, in one condition, the convex lens forms the virtual image. Then what is the condition and what should be the position of object at that moment, whether enlarged image or diminished image forms? This is the question. You write in the answer. Students, write in the answer. Convex lens forms virtual image in one case. What is that? At what time it will forms the virtual image? I want that one. When the convex lens forms the virtual image, it was very simple. For example, this is the convex lens. Okay, the focus is on both sides will be there. This is the focus and this is also focus. If object is kept at here, for example, this is an object. This is an object, okay, and you take two light rays. One light ray is allowed to pass through the optical center, it will go in straight, and other light ray is allowed to pass through the focus, that they will go like this. When they will go parallelly, it will go like this. The light ray which is passing through optical center, it will go straight, and the light ray which is incident parallelly, it passes through focus, right? You know that one. When you do the extension of these light rays in the left side, there the image will be forms. The image will be like this. This is the image. That means this is the convex lens. In case of convex lens, if object is between the principal focus and optical center, the image will be formed on the same side. On the right side, image not forms because on the right side, the distance between the light rays is increasing. That's why right side image never forms. Okay, on the left side image will be formed. That is the virtual image. Virtual image means we can see that image, but we cannot catch on the screen. If you place any paper on that, it will not forms, right? Okay, in case of virtual image, in case of real image, here it is forming the real image, right? So you see the diagram. You have to follow the cursor it here. One letter I am taking, that is passing through optical center, it will go in straight. Another letter I am taking parallelly, that parallel letter is passes through focus, and they are meeting at a point. Here at a particular point, the letters are at a particular point, letters really meeting with each other. That's where their real image will be forms. Okay. Here on the right side, the letters are not meeting because they are moving far away from each other. That's why this objective, these two letters on the right side appears to be coming from a point. When you will extend in the backward and they are meeting at a point, there the image will be forms. This is the virtual image. Virtual image. That means object is left side and image also left side. That's why in case of virtual image, we have to take as image distance as negative, and magnification is positive. Magnification is negative means it is inverted image. Real image formed means it is inverted image. Magnification is positive means it is the erected image. Erected means upright image. Upright image means upper parts appear as upper part and lower parts appear as lower part. Okay, right. If you have any query, students, you ask. This is the last revision. Again, there is no revision. Savan Gop, good right answer. That is, the object should be between the focus and optical center in order to get the virtual erected enlarged image. At this location, it can be used as a simple microscope also. Students, you write in the chat box if you have any query, because this is the last revision, right? One time already explained, and in the revision also I am explaining that there is no further revision. You listen very carefully, okay? Right. I'm going to erase these all things and I am going to explain next topic. Otherwise, I will take it to up. Right. According to sign convention rules, we got the convex lens. Convex lens generally we will take the focal length positive, object distance negative, and for the second concave lens, if you go for the concave lens, in case of concave lens, focal length is always negative. Remember it. Concave lens means focal length is negative. Object distance is negative for anything, right? Concave lens, this is the concave lens, right? And concave lens, if the letters are parallelly incidenting, what happens? This lens is other name. What is the other name of concave lens? Can anyone tell what is the other name of concave lens? The letters will be passes like this. On the right side, these letters never meet with each other. Then we have to do these letters are appears to be coming from a point in the left side. Then you do the extension in the left side. They will meet at a point. There the image will be forms. That is the focus, right? This is the virtual image and diminished image. Okay, right. When object is at infinite distance, image forms at the principal focus, but the focus is left side for the concave mirror. That's concave lens. That's where focal length is positive, negative, and object is generally we kept at the left side. That's where we have to take as negative. Left side distances you should take the negative. That you should remember. Okay, right. Can concave lens forms the real image? Anyone can answer. Is there any chance that concave lens forms the real image? Huh? In any situation where the concave lens forms the real image? No, concave lens is always forms the virtual image. You remember it. Concave lens always forms which type of image? Virtual image. Virtual image. Okay. And diminished also. Virtual image and diminished image forms. Diminished means a small size it will be forms. Okay, right. And now for this, what you have to do, take image distance also negative. You have to take because left side only image also left side forms. Okay, and anything any more are there? Magnification. What about the magnification? Magnification is positive only, right? It will forms the erected image only. Erected means upright image. Upright image. Upper parts appear as upper parts only. Lower parts appear as lower parts. For example, you are see erected image means you are seeing your image in the mirror, plane mirror. In plane mirror, erected image is formed. Okay, erected image formed. Erected means upright. Upper आपका head ऊपर में दिखाएगा, legs नीचे दिखाएगा. That is upright image. Reverse inverted image means if you will see your image, legs appears upward and head appears downward. Means that is the inverted image. Okay. One important point is that while applying lens formula, don't apply the sign convention rules for the unknown value. Okay. That this already I said. Don't apply sign convention rules. Don't apply sign convention rules. Don't apply sign convention rules for a value for unknown value. For unknown value. Unknown means, for example, you want to determine Image distance, you know it as negative, but don't take it as negative. V equal to question mark, that's all. Don't apply sign convention rules for unknown value. Okay, that means unknown value means it should be determined. Okay, right. And the next one is the, what is the formula for the power of the lens? Can anyone tell what is the formula for the power of the lens? Power of lens means what? Can anyone write? Tell what is the formula for the power of the lens? Power of lens. What is the power of lens? Power of lens is the reciprocal of focal length, right? Power of lens is the reciprocal of focal length. Power of a lens. Power of lens is the P. Power means what? After completion of the power, then we start the problems. Okay, right. The reciprocal of focal length. Reciprocal of focal length is called as power of lens. Is called as the power of lens. Reciprocal means what? Power we write as 1 by f. Okay, but the focal length should be in the meter. There is a condition that power unit, SI unit of power is what? SI unit of power is diopter. Okay, diopter is the power unit. One diopter is equal to what we can write from the figure. P is 1, you take f also you should take as 1. Then 1 diopter is equal to 1 by 1 meter, you will get from the above equation. If focal length is 1 meter, then power how much you will get? Power equal to 1 by 1 meter, that you will get as 1 diopter. That means power of a lens whose focal length is 1 meter is called as power of a lens whose focal length is 1 meter is called as 1 diopter. 1 diopter is the power of a lens, but whose focal length should be equal to 1 meter. If focal length is 1 meter, then the power is called as a 1 diopter. This is about power. And if two lenses are we are using, okay, and in case of convex lens, you remember it. In case of convex lens, focal length is positive, then automatically the power also positive. In case of concave lens, in case of concave lens, focal length negative, that's why the power also negative. Okay, right. And effective power, if you want the effective power, then how we can write the effective power? The combined power, if you want. Okay, the combined power we will get like this. For example, we are using the two lenses. Okay, two lenses having the powers, individual powers. Two lenses having powers P1 and P2. Powers P1 and P2 are combined like this. If these two lenses will act as single lens, individually they having the powers P1 and P2, and they are combinedly act as one lens, then its power is P. Then what is the power formula? Then we write as P is equal to P1 plus P2. But you should apply the sign convention rules while using this formula also. Okay, while using above formula, you must apply the sign convention rules. In light chapter, while using any formula, you must apply the sign convention rules. Okay, while using above formula, either you are using the lens formula or magnification formula, power formula, right? In everywhere you have to use the sign convention rules. You have to use sign convention rules. Okay, theory completed. Now we start the problems. Okay, I am going to erase everything. Now the first problem, is it clear till now, students? Yes, Savan Gop, the power formula 1 by F, Priya Mato 1 by F. Very good, you gave the answer. Right, nice. We will start the problems. Right, if you have any query, you ask me. Okay, don't hesitate to ask. Right, okay, let us start. Few problems we will discuss. The first problem is that based on the lenses, we are going to discuss the problems. A concave lens, first either concave or convex, anyone we can write. Okay, okay, we will discuss first convex. A 20 centimeter, right, a 20 centimeter tall object. You also try and note it. A 20 centimeter tall object is placed perpendicular to the principal axis, of a convex lens. Convex lens of focal length 10 centimeters. The distance of object, from the lens is 15 centimeters. Find the nature, size, position and size of image. We have to find out size of image. Also find its magnification. So many questions they are asking to find. Okay, one by one we start. This is the problem number 1, right? How to complete this problem? Can anyone start it in the rough notes? 20 centimeter tall object means what they give in the question. First write the values of the write the given values. 20 centimeter tall object. Object height is 20 centimeters. Okay, object is generally above the principal axis. That's why you have to take positive. And perpendicular to the principal axis, it is the lens is the convex lens. Convex lens focal length you have to take positive plus 10 centimeters. And the distance of object from the lens they give is 15 centimeters. Distance you should take generally negative. Is it? This is a convex lens. In case of convex lens, object distance is negative. Generally, object is kept left side. For example, this is object. Object height you have to take negative positive because above principal axis. And focal length is positive. Object distance is u, that is minus 15 centimeters. And question, find the nature and position of the image. We have to first, there are question, first position of image we can find out. Image distance is what? Size of image you have to find out. Height of image we have to find out, right? Height of image we have to find out. And the nature of image we have to find out, right? There are so several questions are there. And nature means what? Whether it is erected or virtual or what? virtual or real image, that we have to tell. Find the magnification. Magnification also we have to find out, right? First, image distance we can find out. Anyone write in the chat box? Have you got image distance? Write in the chat box if you got. Write this. We will go for the solution. 1 by f is equal to what, 1 by v minus 1 by u. This we have to use. Don't confuse. Yesterday, in case of mirror, you should use plus. In case of lens, you should use minus. In the question, whether they gave the lens or the mirror, that you have to remember. And now start the solution. We will substitute the values. 1 by f is the 10 and 1 by v is the unknown. V is the question mark. We don't know. That's why we have to find out. Minus 1 by u is the minus 1 by 15. Then finally you will get 1 by v is equal to 1 by 10. Here minus minus plus 1 by 15 plus 1 by 15 goes to left side, means minus 1 by 15 you will get. And now do the LCM, that is you will get 30 and 10 3 ja 30, 15 2 ja, then you will get as 1 by 30. From this image distance you will get as plus 30 centimeters. That means image forms on the right side at a distance 30 centimeters, right? Image forms on the right side. Understood, students? Is it correct? Plus 30 centimeters. Image forms on right side of the lens. Image forms at a distance 30 centimeters on right side of the lens. Is it correct? On right side of lens. Next we have to find out the height of image, right? Height of image we have to find out, right? Then for the purpose, how we can use the magnification formula. What is the formula for the magnification? In case of go for the second question. This is the first question solution completed. Second question, height of image we have to find out. Magnification formula, height of image by height of object, that is equal to v by u. In minus v by u for the mirror, but v by u for the lens. Then height of image we have to find out. Height of object, it is 20 and v as v image distance 30, object distance is minus 15. Then this will be cancelled. Then height of image you will get as minus 40 centimeters. What is the meaning of this minus 40 centimeters? Is it minus 40? Height of object is 20 centimeters. Oh, this height of object we have taken as 2.0 centimeters. You remember it. It will change in the question. Height of object is the, no problem. If height of object is 40 cent, if height of object is uh, 20 centimeters, you will get that one. Okay. You have to take the object height only 2.0 centimeters, means only 2 centimeters. Point is there, point. Okay. 2.0 means 2 centimeters. Right? When it is 2 centimeters, you have to take 2.0. 2.0. No problem if you will take that one, right? And this is 2.0. 2.0 means 2 into 2.0 you will get as 4.0. It is nothing but minus 4 centimeters, right? Okay. Next, minus 4 centimeters indicates what? Whether it is image is enlarged or not. Image object height is only 2 centimeters, but image height is 4 centimeters. Okay, not 20 centimeters. You may take it as 20 also. If you will take 20, you are getting the image height as 40 centimeters. Okay, right, no problem. And now this indicates that we can say by this nature also, inverted and enlarged image. Is it right? Enlarged image formulated here. Next, I want, this is the third one. Third nature also we will give from this only, or the magnification we can find out. Magnification, how to find out the magnification? It was very simple to find out the magnification. That formula is v by u, or height of image by height of object you use. V by U formula is what? V is the right side 30 centimeters, U is the left side minus 15 centimeters. Then you are getting the magnification is minus 2. Negative indicates again inverted and enlarged. Is that right? Okay. Solution is completed. Have you any query, students? Yes, Nishant, you wrote right answer, but I changed the object height as 2 centimeters. Okay, that's why a little bit the solution changed. Okay, right. Let us go for the another question. One question we discussed based on the convex lens. Next, we will discuss the based on the concave lens, right? Okay. One more question, problem number two, we are going to discuss. That is based on concave lens. Okay, and now that is very simple to find out that one. That is a concave lens. A concave lens has focal length. A concave lens has focal length of 15 centimeters. At what distance? At what distance should the object from lens be placed so that it forms an image? It forms an image at 10 centimeters from the lens. Also find magnification. This is simple question. Okay, let us go for the solution. Okay, anyone write in the chat box within 1 minute? Concave lens they give, right? It is a concave lens. Concave lens always forms virtual image on the left side only. Concave lens focal length you should take negative. Convex means positive, concave means negative. At what distance should the object from the lens should placed? Object at what distance placed? That is our question. So that the image forms at 10 centimeters. The image distance is 10 centimeters. Image always forms on the left side. That's why concave lens always forms the image on the left side only. Okay, image forms on the left side means image distance is negative. We have to take. What is our question? Question is what is the object distance? What is the magnification? These are the two questions based on this. Very simple to find out. We have to use the lens formula to find out the object distance. 1 by f is equal to 1 by v minus 1 by u. 1 by f is the minus 1 by 15, that is equal to 1 by v is the minus 1 by 10 minus 1 by u. U is we have to find out the u. Okay, then from this 1 by u is equal to we will get as minus 1 by 10 plus 1 by 15 you will get, then again 30 you will get minus 10 3 ja 15 2 ja minus 1 by 30 you will get. Then from this 1 by u is minus 1 by 30. From this u is equal to you will get as minus 30 centimeters. Object should be placed at minus 30 centimeters. Right, Nishant? Okay, next I am going to explain one more point. You find the magnification now. How to find out the magnification? Can you tell how to find the magnification? Okay, magnification formula you know already, height of image by height of object we can use, or the image distance by object distance you have to use. Okay, what is the height of image by height of object? In the question whether they gave the height of image and height of object or not. No, not give. That's why we should not use this formula. We have to use v by u formula, right? And from that magnification formula v by u, you have to use v is what, minus 10, u is what, u we find out that is minus 30, right? That means we got the answer as 1 by 3. That means magnification here it is less than 1. If it is okay, it is 1 by 3. 1 by 3 means it is a diminished image is formed. Okay, diminished means a small size image height is less than the, okay, you see, if you from this, if for example magnification is 1 by 3 means height of image by height of object is 1 by 3. From this, height of image is 1 by 3 times of height of object. That means height of image is less than the height of object, right? That means it is a diminished image form set here, diminished image. And virtual image, why it is virtual image? Actually, convex lens is a diverging lens. Na? Diverging lens always forms the diminished image and virtual image only. Concave lens always forms the virtual image. If object is at infinite distance, this is the diagram, not for this case. Okay. Now, if you want to draw the diagram for this case also we can draw. Let us see here, we will draw the diagram. I think already we drawn the diagram in the general, during the general class. Okay, you listen very carefully. This is the optical center. Okay, and this is the principal focus. Principal focus at what distance? 15 centimeters, right? 15 centimeters. And the object is placed right here. Okay, this is the object, and you take one light ray that is passes through the optical center. It can go in the straight without any bending. It will go in the straight like this. And one more light ray you take that is incident parallelly on the principal axis. When light ray is incident parallelly, what happens? It will be diverges. It will be diverges. Diverges means how it will travel? It will go like this. And now this is appears to be starts from the focus like this. You do the extension for these two light rays backward. These two light rays which are refracted through the concave lens, they cannot meet on the right side because they are moving away from each other. That's why on the right side image not forms. But these two light rays you can extend in the backward. These two light rays when you will extend the backward, these are appears to be coming from this point. At this point the image will be forms. Image forms it here. Image forms it here. This is the image. Got it, students? This is how to draw the diagram. And object distance is this one, right? Is the 30 centimeters, but the image distance is only 10 centimeters. The focus distance is 15 centimeters. That means object when it is infinite distance, an image forms at the focus. If object is between the infinite and focus, an image forms between the focus and the optical center. You see here, object is back of the focus and image forms between the focus and optical center. Have you understood, students? Right. Now let us go for the one more problem. If you have any query, you write it. Write in the chat box, students. No query, na? Okay, I'm going to continue. I'm going to erase this one and I'm going to start the next problem. Only two, three problems, one or two problems next I will explain and I will close today's lecture. It's not erasing. What happened for this? Yes, now it is erased. Right, next problem is just we will discuss one problem based on the power of the lens, right? Power of the lens. That is, if the power of a concave lens, they give one question like this. Okay, you see here. The question is that very simple. It is easily you can write the answer. Find the find the power of a concave lens. Find the power of a concave lens of focal length. Focal length 2 meter. Focal length 2 meter. Right, this is our question. Write the answer, students, very easy. I will give 1 minute time for you. You start and complete the answer. Write in the chat box, students. I am expecting answer fastly. Okay, very easy. Use the sign convention rules also. Have you completed? Right, Nishant Kumar minus 0.5 diopter. Yes, the focal length they give is 2 meters, right? But the we have to, in the solution, what you have to do here, this is the concave lens. In case of concave lens, what you have to take according to sign convention rules, the concave lens focal length is negative, that means minus 2 meters. What they are asking to find out, they are asking to find out the power of the lens. What is the formula for the power of the lens? That is 1 by f, but f should be in the meters. And the power you will get in the diopters. Is it right? Very simple question, right? Then 1 by f is 1 is 1 by 2 diopters. Then power we are getting is minus 0.5 diopters, right? Completed. Next, we will go for the another question. In 10 minutes, I will close. Let us go for the next question. That is a convex lens. A convex lens forms a real and inverted image. Real and inverted image of a needle at a distance 50 centimeters from it. Where is where is the needle placed in front of the convex lens if the image size of image or the image size we can take image size is equal to the size of object. Also find the power of lens. This is our question. I don't know whether you will give the solution or not. Once read yourself and try for the solution. A convex lens forms the real and inverted image. Convex lens forms the real and inverted image of a needle at a distance 50 centimeters from it. Where is the needle? Where is the needle placed in front of the convex lens? If the image is equal to the size of object, at what condition? Where we have to place? Actually, in case of concave mirror, if object is placed at the center of curvature of concave mirror, the image will be formed at the same size. Inverted image will be formed. This is the focus, and this is the 2f, 2ff, and this is f and 2f. Right now, at what location we have to place the object to form the same size image? Okay, this is our question. Convex lens forms a real and inverted image of a needle at a distance 50 centimeters from the lens. Image distance they give, right? Image forms, that is the image is real and inverted. Convex lens forms a real and inverted image at a distance 50 centimeters. Image distance they gave as 50 centimeters, right? Image distance they gave as 50 centimeters. And height of image is equal to height of object they give, right? And for that, where you have to place the object? This is our question. First question, where you have to place the object. Second question is that find the magnification, sorry, power of that lens also. This is our question. Okay, in order to find the power, we require the focal length, right? Okay, now if you place the object anybody answered where we have to place the object? Very good, Nishant. Object should be placed at 2f, right? Nice, nice, nice answering, Nishant. If object is placed at 2f. If object is at 2f, okay, you take two light rays. One light ray parallelly incident and it passes through focus. Another light ray passes through optical center. It will go in straight like this and they will meet with each other and here the image will be forms. This location is the 2f. This is the image. And here object height and image height is same. Okay, that means in order to form the image with the same size, right, object should be placed at 2f. That means object is placed at 2f. That means object distance is equal to minus 2f. That is equal to minus into 2f is what? Focal length. We don't know focal length. We have to find out the focal length. Okay, then for the purpose what we have to do, image distance is also equal to double of the focal length. This is the f, this is 2f, means 2f distance it will be there. That means image distance they gave as 50 equal to 2f. From this f is equal, we will get as 25 centimeters, right? And object distance is also, right, minus 50 centimeters. Object is at 50 centimeters, image also at 50 centimeters. Object distance, image distance should be equal. And focal length should be equal to 25 centimeters. The power of the lens is what? 1 by f in the meters, right? 1 by f. F is what? You convert this into meters. 25 by 100 you have to do. Is it right? 25 by 100 in order to convert into meters. You will get as power as plus 4 diopters. Understood solution, students? Is it clear? Any doubt? Any query is there? Write in the chat box. If you have any query, write in the chat box. Clear na students? Right. We will go for the next problem. Next question is that okay, find the find the focal length. Find the focal length of a lens of power minus 2 diopters. Minus 2 diopters. What type of lens is this? What type of lens is this? Write in the chat box, students. Write in the chat box solution. Okay, I'm giving the 1 minute time for you. Write in the chat box. Concave lens. Hmm? Focal length negative, right? Power negative they give. Power is given as minus 2 diopters. Power negative for the concave only, right? Okay. Focal length we have to find out. Very simple. Right? The power is equal to 1 by f. Then from this f is equal to 1 by p. Then we write as minus 1 by 2. That is focal length is the minus 0.5 meters. The lens is the concave lens. Very simple. Right now? Okay, completed. Next. One more question, last question. Two lenses, a convex lens of focal length 5 centimeters and a concave lens of focal length concave lens of focal length 10 centimeters are combined, then find the effective power of these two lenses. Okay, effective power we have to find out. This is our question, last question. Okay, after this we will close. Okay, what they are asking in this question? There is a convex lens. Solution we will go directly. First, convex lens. Convex lens focal length is what? 5 centimeters. Okay. Uh, and if you want to find the power of this one, 1 by f1 we have to take. But f1 should be in the meter, na? Then we can convert into meters first. And for that, convex lens has the focal length positive, right? Plus 5 by 100 we have to do in order to convert into meters. Then we have to find out the power of this first lens. 1 by f1. Anybody, if you have the answer, you write in the answer. 7, 10 diopter. Is it find effective power? How you got 10 diopter? 1 by f1. We will check once. 1 by f1 means here you will get 100 by what you will get. F1 is 100 by 5 by 100. That will go to numerator. We will get as 20. Plus 20 or minus 20? Convex plus 20 diopters. Next, another one is the concave lens. Concave lens has the focal length how much? 10 centimeters. This also converted into meters, 10 by 100 meters. Then power of this lens also we can find out. Oh, one thing we did the mistake, but the concave lens focal length is negative. Is it right? And 1 by f2, but the focal length should be in the meters, right? 1 by f2 is what? Minus 1 by 10 by 100. Then finally we'll get minus 100 by 10. What you are getting it here? Minus 10 diopters. If these two lenses act as single lens, convex one and other one is the concave. If these two are combined like this has the for f1 and this has the focal length f2, these two are combined. And if these two act as single lens, then their effective focal length or the effective power we can find out. Effective power, how we can find out? Just I gave the formula for the effective power also. What is the formula? P is equal to P1 plus P2 I said. P1 is what? 20 diopters. Yes or no? And P2 is what? Minus 10 diopters. That means P is equal to what you got? Plus 10 diopters we got. Effective power is plus. Means effect these two combination will act as convex lens. Is it right? These two combination, a convex, a concave, but the combination will act as convex lens. Its power is we got positive. That's well. It is convex lens. What is the effective focal length if you want to find out? How to find out the effective focal length? Effective focal length means it was very simple. There is a power is equal to 1 by P equal to 1 by F. Then F is equal to 1 by P we will use. And effective focal length we write like this. F is equal to 1 by P. That is 1 by 10 diopters. Effective focal length is 0.1 meters. If you convert into centimeters, okay, 10 centimeters you will get. This is the effective focal length, right? Is it correct? Right. The effective focal length is 10 centimeters. Is it correct, Nishant? Savan gave 10 after right answer. Okay, students, I am going to close. Thank you to all. On Monday, you have the exam, no? Prepare properly.